Welcome back to STEM Online Academy. My name is Jason Masterakos. For those of you who don't know, I'm not going to go into introductions. Let's get right to it. This video is specifically about why even smart students can freeze on hard calculus exams. Okay, so why they freeze? Okay, you'd be surprised, right? And it's not because they don't have it, like they don't have what it takes. That's not what it is. There's a multitude amount of factors as to why um, even smart students can mess up in a calculus-based course. Okay, one of them we're going to get to. Actually, I have a small list. I'll get right to the point. I can give you a slew of reasons why. Okay, but what you're going to learn from in this video is going to be pretty handy. Okay, I have it written down just to remind myself. We're going to be discussing why memorizing formulas is not enough for real calculus courses, real or calculus exams plus courses. Why unfamiliar problems actually create panic. Okay. I mean, like emotionally, like where you just freeze up and you can't think at all and everything just goes sideways. Okay. How strong students actually think before solving. Okay. We all make this mistake at one point. I made this mistake at one point. Okay. But you have to learn to correct yourself. Right. Why visualization and modeling, right, has to come before execution. Okay. Again, I repeat, why visualization and modeling has to come before the execution phase, right, for when it comes to problem solving. Okay. And then finally, how to begin building real mathematical intuition. Okay. All right, so let's get to it. So let's answer the first question to the best of our ability. These are some thought-provoking questions I'm posing here. Okay, so why is memorizing formulas not enough for calculus exams? I'm sure you've taken calculus courses, and well, it depends who's teaching it. If you have an easy teacher, right, then he's going to, and there's too many of those, he's going to give you a slew of formulas. The problem with this, here's the problem with the formulas, okay? If a professor gives you all the formulas, right, like right away, and that's all they're talking about is the formulaic part of the course. The problem is you know it, but you actually don't know it. Okay, there's a difference between thinking you know something and actually really rigorously knowing it deeply. Okay, all right. So yeah, so what's wrong? The formulaic part, it's just some sort of algorithm. Take a moment to think about that, right? It's just an algorithm, right? So you can plug chug, and this algorithm will work again and again and again. The problem is this algorithm, right, is only going to work again and again and again on the same type of examples. But same type of examples isn't math, right? It's just regurgitation. Okay. Regurgitation is not going to help you when it comes to um, hard calculus based problems. Okay, so that's one problem, right? When it comes to um, why formulas are not good, right? What matters more is if you can derive the formulas yourself. Okay, right? Try deriving them. Even well, usually your professors will, if you're university, not in high school. I think this type of thinking should be um, that brings a good thought-provoking question. I think this type of thinking should be start in end of grade 11 to 12 to prepare you for university. Because even if because you take calculus in grade 12, but then you take it again in university. Uh, the thing is, in university, they're already going to do the derivations for you. So if they do the derivations for you, even that you probably you won't understand because you just memorize the derivation. What you should be trying to do, especially if you're a high school student, try to derive um, the formulas yourselves. and only the formulas that you haven't been shown. Like if a teacher or prof has not actually did the specific derivation of a formula, okay, do those ones. Don't do rederivations if they've already shown you. If they've already shown you how to derive it, it's pointless of you doing it again, right? Right? Because the point is for to challenge yourself and to learn something and learn how to think, right? But if the teacher has already done it for you, there's no point in doing the same derivation again if they already have it on the whiteboard or chalkboard. Okay. And this type of thing, I think, should be started at grade 11, end of grade 11. I think is appropriate. I think that's reasonable, right? Right. So you want to be able to shift your thinking to that. You want to shift your thinking to almost like a way of a problem solver, as instead of someone who is just regurgitating back the same thing. Okay. So that's the problem with formulas. All right. Now, as I said, there's going to be a few things I want to bring up in this video. Another one is why unfamiliar problems are going to create panic. Okay, so why unfamiliar problems create panic. Right now, here's the thing. Okay, that a lot of you have, right? Especially when you're given homework. Right. This is why homework is. I'm not saying not to do homework. But what I'm saying is, if your teacher is giving you homework on exactly the same type of problem, for instance, let's say you had y equals x as one problem. Let's say the next problem says y equals x squared plus x. It's not really giving you anything in terms of practice, in terms of your problem solving, because it's just um, mainly algorithmic. It's mainly just regurgitation of the same problem with just slightly something else added to the problem, if you know what I mean. Okay. What you need to do is when you do practice problems or homework, whatever the hell you want to call it, is you want to be able to choose problems that are all unfamiliar, right? Let's say you, and of all ranging of different difficulties. I like to start off with difficulties of, uh, I'd say upper end of intermediate all the way to very difficult, or difficult to very difficult. That would be more realistic. Don't do any of the easy problems. I mean, you do one, right? Do one and see how it goes. More likely you're going to get it, but that won't give you anything. If you do from the upper end of an intermediate problem to a very hard problem, work yourself up to hard to very hard. Okay. If you do that, what you'll get out of it is much more than doing 1,000 of the, very easy problems. Okay. It's gonna train you to be prepared for those hard midterms or exams, right? When you see something unfamiliar. Right? In other words, they train you to sort of think and approach things in the moment, whereas the other ones give you a false realization that you think you know it, right? So that's the main thing that's important here. Okay. Another question we need to um, answer that I mentioned that will be in this video is how strong students think before solving. Now, if you've watched my other videos, right, you probably know that I already have a specific system that I've used for problem solving. At least my system. Okay. You may have to choose your own system if you don't like my system, or if my system is a little bit too abstract. Okay. The point is, you need a technique or system to help you go through the problems. Okay. So, for instance, right? How should I go about it? Yeah. So when it comes to any of these problems, what's majority of the good students, very good students do actually, from my experience, is they will have an approach to solving it, right? They develop some step by step chronological process to solving a problem. Okay, it's very effective. Okay, well, effective for them. What works for them may not work for you. Okay, but quite often almost all of them, we can agree, have an effective system that helps them do the problem solving. Okay, my technique, I can always go through it with you guys again, maybe a bit later in this video. But everyone, you have to find what specific technique is going to work for you. that amplifies your abilities. Okay, so that's when it comes to problem solving, right? How strong students think before solving a problem, right? The other question is why visualization and modeling must come before execution. Now we're getting into my technique, and if you want, you can use my technique and why it can be handy. Okay, pretty much my technique is interesting, and it helps in a lot of areas in mathematics, right? Right. It's starting off with visualization, right? So step one is you want to be able to visualize what you're dealing with. Now, when it comes to a problem, let's say, obviously this is most applicable if you have a geometry problem or problems involving graphs, vectors, or whatever. Okay, then visualization is a must. All right, pictorial visualization. Okay, but even if the problem doesn't require any type of graph or geometry involved, you can still visualize it. Right, right. All it means is that you're applying um, some sort of process in terms of a plan of attack, you can say. Okay, a plan of attack of how you're going to approach the problem. Okay, but you want to be able to visualize first. Okay, you want to visualize the problem first, regardless. Then you want to transition to step two, which is modeling. So if what I mean by modeling, this is where you're gathering all of the important facts that you know or don't know, and you come up with a plan of attack in modeling for sure. If it's on visualization, it's going to be in modeling. Okay, what you know, what you don't know, all that stuff is very important. All right. So modeling is step two. Okay. And then after we have execution for step three. Now, does visualization and modeling come first? Well, the execution, right? The execution phase, you can't execute if you don't know what your strategy is to attack the problem. You have to have some strategy. You can't just go into execute and say, "Oh, I'm going to do some sort of fancy algebra." No, you have to know what you have and don't have, and you need to have some sort of model, some sort of a visual model of what's happening, right? You take the visual model, right? From the visual model, you will map it to the actual modeling phase, right, where you have your plan of attack, and then you go into the execution phase where you have to plug and chug, or maybe do some sort of algebraic manipulation. Okay, it's always important to have water when you're speaking. All right, so that's very important. Right? So this is the reason why visualization and modeling comes before the execution phase. Okay, so that's very important. Okay, so visualize, model, then execute. Okay? And then the last step in my technique for solving problems is you want to verify, right? I should mention the verification phase is last. I think it's obvious. I don't think I need to explain it, but you always need to verify what you're doing in a STEM course. Okay, without verifying, everything is just hand wavy. Okay, so you need to verify what you are doing. Right, and finally, the last question we need to ask ourselves. Okay, let's see here. What was it that is written down? How to begin building real mathematical intuition. How do you do that? I want you to think about how do you build real mathematical intuition? Is there a way to do that? Now, some people think, oh no, you can't. That it's something that is a sixth sense that you just actually have to have. No, I mean, some people do have it. Some people greatly have it to a degree that's crazy. Um, but even if you, more likely, you're not going to get to that. But you can still build some sort of uh, sixth sense, you can say, when it comes to solving math problems. Okay, and the best way to do that is to do a lot of different problems. Well, sorry, for the problems, understanding the theory very well. Okay. You need to understand the theory for whatever you're doing very well, right? Like very deeply. Don't just read it, question it, and then you have to ask yourselves correct questions, right? Read it, ask yourselves questions on the theory, and even try to explain it to somebody else in a very simple form. If you cannot explain it to somebody else, you don't know it, and you need to go back to the theory, right? By the way, this is something by Richard Feynman. Feynman was a theoretical physicist. Okay, he came up with the Feynman technique for learning. So I'm applying part of his technique, right? So it comes down to that, right? Right. So you need to be able to both uh, read, write, and then hopefully you can communicate it to somebody, right? Till then, you don't understand it. Read, write, communicate. So understanding the theory first, and then once you've understood it, try and do as many problems um, that you can do. I mean, you have to do a whole slew, but math is not a spectator sport. You have to get into the fire, if that makes sense, right? You have to do it yourself, right? Even when it's painful and you don't feel like doing it, you just have to go into it and just say, okay, I'm going to try this and see if it will work. Okay. So constant, constant practice with both an interplay of the theory and the problems. The theory is more important though. Without the theory, if you don't understand the theory, the problems mean nothing. Okay. Yeah, everything comes down to theory first. All right. So what I want you to take away from the video is that you need to have, especially when it depends on the teacher or professor too. I find, like whether it's an easy or intermediate or a very hard professor, uh, you have to either tailor your learning style to that, and maybe even have to develop learning techniques, more rigorous learning techniques in order to do well. Okay, depending on who you have, right? So that's really really important. Okay, so especially when they give you hard exams, right? But you want to be well prepared before then, because by then it's too late. You want to have your mind sort of set in a way that is like, okay, I'm used to things that are unfamiliar. I have a system for approaching problems that are unfamiliar, and I'm going to go with that. Okay, and that's what you need to start training yourself to do. Okay, so for homework, I want you to use my technique. Okay, specifically when it comes to, let's think, if you were if you're an AP or IB, use it for analytical geometry, slash calculus problems would be really handy. If you're in university, try using it again for that, or for any other type of course that's calculus oriented, physics oriented, very much so, right? Because everything is visualization when it comes to physics. Okay. Right. So please try and use that. Try and incorporate it into your everyday learning. Okay. Also, in at the end of this YouTube video, you can always put things in the chat. Okay. Uh, you know, put anything you want. You ask me questions. If you want to scrutinize me on something, go ahead. You can put it into the YouTube chat. Okay. Underneath in the video below. Right. All right. So I always like having conversations. Anyways, if you have trouble understanding, or you want uh, more information on how this my technique works for solving hard calculus problems, you can always contact me for anything. I also have a free PDF that is about the technique that I'm using. Okay, right? It's a semantic model, pretty much. That's what it is, right? And I list where in majority of calculus courses that this would be really important to apply, right? What to look out for, what you know type of you know limit or derivative or whatever you have to do, where this will come up. Okay. So if you don't understand it, please, there's a free link, a free PDF, one of the links in the description below. And if you need even more help, let's say, for instance, you understand a good amount of calculus, right? Like you're for looking for I don't know, more of a logical foundation. Um, as I said, trying to avoid the formulaic nonsense in calculus courses. If you want a more of a logical foundation to where calculus comes from, you can check out my link for the description for axioms in the link below. I'm going to list the book title there. It's very handy. It's a precursor. It's a good, very 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 good prerequisite before doing calculus. At least you know where the calculus comes from, as opposed to having someone giving you formulas. All right. So that will be in the description below. And if you need more help, I am always available for one-on-one coaching. One-on-one coaching, face to face, online though, but it'll be, me talking to you. It's one thing when you have a resource and you're reading it, and it's another thing when you're actually talking to someone. Sometimes something can actually help, something can trigger when you're talking to somebody else. Okay, at least in the learning process. So I'm always available for um, one-on-one teaching. Okay. If you enjoyed this video, like and subscribe. I want to say thanks to current subscribers. I appreciate it. But new guys, please like and subscribe. It always helps the channel. Okay. And I'm going to try to do two. If I don't do two this week, yeah, I'm going to try to do two, probably on Sunday. There's a new schedule, by the way, somewhat of a new schedule. Still, I'm going to be on Tuesdays, Eastern Standard Time, preferably 4 p.m., and Sundays. Look out for Tuesdays and Sundays. I'm going to pop in where I'm going to be discussing how my approach to hard calculus problems, um, calculus-based physics, and introductory logic for calculus can really help you skyrocket your grades. Have a good day, guys. It's always a pleasure. Bye bye.